Good morning and good afternoon to everyone, and welcome to the AWS Partner Executive Briefing Series, Mission Critical Solutions for the Public Sector. Today's topic is Drive Meaningful Outcomes for Better Societal Impact Using AWS Artificial Intelligence. Before we get started, I'd like to go over a few housekeeping items. Please note that you're listening and using your computer speaker system by default. If you would prefer to join over the phone, just select telephone in the audio pane and the dial-in information will be displayed. You will have an opportunity to submit questions to our presenters by using the question pane of the control panel. You may submit your questions at any time during the presentation. We will respond to your questions within 48 hours after completion of the webinar. Thank you for your participation.
Hi, my name is Sandy Carter, and I'm Amazon Web Services Vice President for Public Sector Partners, Startups, and Programs. And I'm so excited that you've joined us here today for our Partner Executive Briefing on AI and ML, two of my very favorite topics, by the way. And I wanted to welcome you and at the same time say thank you for coming, because I know we're all in now this new virtual world or the new normal. I thought this cartoon was really cute. I can't remember, do I work at home or do I live at work? I know all of us feel that way, and we've been virtual meeting out. So I really appreciate the fact that you've joined us today to learn a little bit more about AI and ML in this new normal world. I hope that you're safe and that you're healthy, because you do matter to us. And we will prove to you that today was an actionable and valuable session as we go through. So let's start out where most of our customers start out, which is they all want to innovate, right? And to innovate, you can't just do it with technology, and you can't just do it with the business. You need both. So as we're thinking about AI and ML today, we do want to combine the business value and the thoughts, especially around the data, and then the technology itself to truly innovate in this space. I know that AI ML is one of the top areas that our customers are looking for, and they're looking for you to lead. If you think about the opportunity, it is tremendous. And this doesn't even capture all of it. This is the worldwide artificial intelligence forecast, and it's projected to be $300 billion by 2024, which is, you know, if you blink your eye, we're going to be there in a minute. And it doesn't really even assess all of the other areas that are associated with artificial intelligence. Getting the data ready, making sure you've got the right models in place. So this is a big opportunity area, and one that we know customers are asking about tremendously to understand how they can innovate in the future. So in today's executive briefing, what we'd like to do is talk you through the focus, how you can get activated, and then how you can scale up, because that's what we all want to do, right, is grow. So let's start first with focus. I have this little picture over here on the left-hand side. I think it's kind of cute, but it also tells a story. When you talk about data, you know, data is really important, and we learned this tremendously during the pandemic. You needed data to get food sources where they needed to be, to get masks where they needed to be, to ensure supplies got through the right supply chain. But in order for that data to be used and important, it had to be sorted, it had to be arranged, it had to be presented in such a way that it told the story. You also needed the right data source, the right data quality, and the right data quantity. So all AI and ML really starts here. And for our partners, as we go forward, we really know that this is about talking about the solution that includes the data, and ensuring that we as a group are not just talking about compute and storage, but that we're also talking about the data, how it can be used, how it can be shaped to produce more value. I know that a lot of people say that data is oil, but I love to say that data is soil from which everything else grows, and one of those things is AI and ML. Now, if we talked about how you can get activated, competencies are really important in the space. Machine learning and data analytics provide you with some of those crucial skills that you'll need to show to our customers. There are a couple of learning paths as well that I want to point out to you. One is around machine learning, and one is around data analytics. And then, of course, there's a ramp-up guide as well. I would encourage you to go through both the data and the machine learning areas to really get yourself enabled and activated, as partners who have a higher skill level tend to generate more revenue. And finally, of course, we want you to scale up. For that, globally, we created an initiative called the AI ML Rapid Adoption Assistance. It's specifically today for public sector partners. We have had tremendous response to it. In fact, today I did 5 or 6 partner meetings, and every one of them wanted to learn how they could get this assistance. It helps you with visioning, piloting, and then eventually to lead to something that has great value for your customers. And then, of course, once you have that, since every partner is now putting AI and ML on everything they do, learning how to differentiate your message and showcase your value is crucial. Our partner marketing team can help you tell that story better and get the right set of campaigns out the door as well. So I hope you enjoyed today's session. We really want you to go and lead in the space. Our customers really demand it. We want you to be able to move beyond just compute and storage. Compute and storage are absolutely essential, but our customers are really seeing the value of those partners who can also talk artificial intelligence and machine learning. In addition, you need to build the skills here, not just on AI and ML, but also data skills, or partner with someone who's really good in that data area. And finally, of course, scaling this out. There are a whole set of programs and initiatives that you can use to help you in the space. So now let me turn you over to my esteemed colleagues that we can help and get moving on our AI and ML session. Thank you.
Thank you, Sandy, and good morning, everybody. I am Wilfred Justin from Amazon Web Services, Worldwide Public Sector. And today I'm joined by 3 distinguished guest speakers, Matthew Clark, Nicholas Jacquard, and Topher White. Dr. Matt has a PhD in geography, and he applies deep learning techniques and artificial intelligence in preserving nature and conserving endangered species, and he is very active with a number of nonprofit organizations. Dr. Nicholas is a principal artificial intelligence architect from Orbis International, which is a nonprofit organization which fights against avoidable blindness. And Nicholas has built a number of algorithms and products using artificial intelligence, and he's very keen on building workloads for social good. And we have Topher White, who's the Chief Operating Officer of Rainforest Connection. And Topher has been named as an engineering hero by IEEE, and he's a Draper Richards Kaplan Fellow, and he has been the CTO for a number of startups in Bay Area. So thanks, Topher, Nicholas, and Matthew for your time today and joining me in this discussion. So today's theme is to drive meaningful outcomes for better societal impact using artificial intelligence. So we will stick on to the theme, discuss a couple of use cases and case studies, and I will highlight a couple of use cases. And I will also provide a brief overview of the AWS machine learning stack, its value prop, and its differentiators. AWS partners and customers have built workloads, machine learning workloads on AWS cloud computing platform across different verticals, spanning from finance to healthcare to life sciences and nonprofits and many more. And the use cases that have been addressed by AWS machine learning stack includes precision medicine, predictive maintenance, process automation, public safety, and of course, workloads for social good. So in fact, 10,000 plus customers, more than 10,000 customers are actively using our AWS machine learning stack. And we have twice more customer references than any other cloud provider. And for those who are listening, you will understand and appreciate why more machine learning happens on AWS once you hear the value prop and differentiators of the platform in the next couple of minutes. So to highlight a couple of use cases, I'll start from the bottom. So we are still fighting and trying to find cure for diseases like Alzheimer's, autism, COVID-19, and cancer. But when it comes to deadly diseases like cancer, artificial intelligence can play a vital role in expediting the research, in drug discovery, in what is known as toxicology predictions, and providing better screening techniques. For example, companies like Celgene is already working with AWS in their fight against cancer. They are doing a lot of cancer research using AWS machine learning stack. And they are also using frameworks like Apache MXNet on top of AWS machine learning stack to provide toxicology predictions. So if you think about it, it takes a couple of $2 billion and a decade to release a drug, and artificial intelligence can play a very vital role in expediting the whole cycle. So when it comes to breast cancer, we collaborate with a number of nonprofit organizations, as mentioned in the slide, breastcancer.org and PHDA in their fight against breast cancer. Breastcancer.org has built a recommendation engine on top of AWS Cloud Computing Platform using AWS Machine Learning Stack to provide recommendation for cancer patients. Because once you're diagnosed with breast cancer, each person's situation is unique, and they have number of treatment options, number of counseling options, and they're literally confused about the next steps that they can take. This recommendation engine takes pathology reports and other kind of reports as an input and provide well-informed information to the patient so that they can take decisions about their next steps when it comes to dealing with the breast cancer. When it comes to PHDA, we collaborate with University of Pittsburgh's Medical Center, as well as Carnegie Mellon, and we collaborate together in fight against breast cancer. And they are building, using AWS machine learning stack, they are building three things, right? One is to provide biological markers for depression, to find out the factors that is responsible for for the tumor growth. And the most important thing is they wanted to come up with better screening techniques for physicians. Physicians currently have traditional techniques to screen breast cancer, but the research scientists there, they're using deep learning specifically on mammogram images, hundreds of images, and they're looking for patterns using neural networks, and they can flag high-risk patients, and they can do cancer mitigation so that physicians can take preventive actions and they can intervene at the right time. So it's a very interesting case study. I would encourage you to go through the AWS blog, or you can directly go to the Pittsburgh Health Data Alliance website to learn more about it. The second use case that I want to highlight is about applying artificial intelligence in fighting against human trafficking. Thorn is a nonprofit organization, and it works with our technology partner, AWS technology partner called Digital Reasoning. And together, they have built a solution that runs on AWS Cloud Computing Platform. They're using their own machine learning algorithms, but they have deployed it on AWS Cloud Computing Platform in the fight against child trafficking. Think about it. Millions of kids are trafficked across the globe. And though we have law enforcement agencies across the globe and across the states, it is a poignant fact that children get trafficked every single day. And this is a perfect example on how we can apply technologies, specifically deep learning, for fighting against it. So what Thorn has done is they've built a system that can scan through hundreds and thousands of ads targeting children, and they can comprehend the ads as a human would, which means that they can understand the figure of speech, they can do sentiment analysis. So whether it is explicitly stated or implicitly implied, they know that these ads are bad, these ads are meant for child trafficking, and they can flag those ads, work with the local law enforcement agencies, and take down the ads. The third case study that I want to highlight is about saving endangered species. And I believe that it's our moral responsibility to protect this planet Earth and save endangered species to pass it on to the next generations. So what happened in Indonesia was orangutans, which is a very intelligent species, their population was reduced by 50% in the last couple of decades. And the data that they have is pretty staggering. So the World Wildlife Fund in Indonesia wanted to fight against it, and they built an entire system using AWS Cloud Computing Platform and using AWS Machine Learning Stack. So they just deploy a bunch of cameras and other devices, and they capture images of orangutans in their habitat. And the goal is to identify every single member in the species. They want to name every single member in the species, so that they can identify their gender, their age, their name. And by processing the images and videos using deep learning and neural networks, they can find out whether they are sick, they are pregnant, and they can proactively go and help them. So this is how technologies can be applied to identify, track, and tag, and eventually protect endangered species like orangutans. So there are a lot more interesting case studies around applying machine learning for social good. And our guest speakers will be talking about 3 more use cases in detail. But before that, I just want to talk about the value prop of our AWS stack in a few minutes. So when it comes to machine learning, our mission at AWS is to put machine learning in the hands of every single developer, meaning that the developer in your organization could be an expert machine learning practitioner, or he could be a pure application developer with absolutely no background on machine learning, or you could have a bunch of data scientists. Irrespective of the background, everyday developers should be able to leverage our stack, and they should be able to build sophisticated artificial intelligence based applications pretty quickly and easily. And that's our mission. And we do that by providing a very powerful machine learning stack. And probably, I'm assuming that you would have gone through the Gartner Magic Quadrant. AWS was named as a leader when it comes to artificial intelligence developer services. And that's what I'm going to talk in a few minutes. So when it comes to the stack, we have 3 layers of the stack. The bottommost layer is meant for expert machine learning practitioners. So these are guys who are extremely comfortable in choosing the algorithm, choosing the framework given the use case, and they can tune it, tweak it, optimize it, and they're also comfortable in dealing with the infrastructure, spinning up clusters and shutting down the clusters once the training is done. So for those kind of machine learning experts, from the bottommost layer, we provide 3 things. Number 1, we provide performance. We provide really powerful machines to deploy the machine learning workloads. And as you might already know, we have compute optimized, storage optimized, and memory optimized instances. But when it comes to deep learning and machine learning, those algorithms are hungry for large volumes of data, and they are massively parallel, and we need to have powerful GPU instances. And that's what we do. At the EC2, we have really powerful GPU instances, FPGAs, and so on. The second is flexibility. And we, based on our interactions with the customers, what we have learned is our customers use different kind of frameworks for solving different kind of problems and use cases. So as a cloud computing platform provider, we want to support multiple frameworks when it comes to machine learning and deep learning. And as you can see, we support multiple frameworks, including TensorFlow, MXNet, and PyTorch. So that's flexibility. And we also provide a lot of cost optimization. When you're deploying your machine learning model after it is being tuned and trained, you can leverage things like elastic inference and inferential chips to reduce your cost. So that is the bottommost layer. Going back to the topmost layer, it is called artificial intelligence services, because behind the scenes, we have a lot of pre-trained models, and these artificial intelligence services are meant for application developers with little or no background on machine learning. They should be able to invoke those kind of those higher level services like they invoke any other services from AWS like S3 or DynamoDB. They just invoke an APIs, send an input. Behind the scenes, we do the heavy lifting, and we give you back the output. So the artificial intelligence services, the goal here is existing application programmers, developers can augment their existing applications, or they can build sophisticated applications, including ASR, NLP, and NLU without having any kind of background. That is our topmost layer. When it comes to the middle layer, this is all about building a custom machine learning model. So all the 3 examples and case studies that I explained involved building a custom machine learning model. And Topher, Matt, and Nicholas are going to talk about their case studies. It all involves a custom machine learning model. But building a custom machine learning model involves a lot of tasks, and it is usually cumbersome. You have to start with the data, then you have to have an environment to build your machine learning model. You have to choose the frameworks and algorithms, you have to optimize them. And when it comes to tuning and training the model, you have to spin up huge volumes of huge clusters. You have to scale the clusters up and down. And finally, when you deploy it, you have to implement all the best practices in production environment, right? You have to implement all the best practices of the cloud when it comes to resiliency, scalability, and security. SageMaker abstracts all the complexities and makes it much easier for you to build a machine learning model much quicker and faster. For example, as you know, data should reside in S3, And if it does not, you can use other services like Glue to extract the data and put it on S3. And once it is on S3, it is seamlessly integrated with SageMaker. SageMaker can ingest the data, and it is based on notebooks, Jupyter notebooks, which has hundreds of examples. So you can quickly start building a machine learning model. And you can choose, right? The next step is you need to have algorithms and frameworks. So this is SageMaker comes with 17 different most widely used machine learning algorithms as part of it. It's not only that those algorithms are pre-built into SageMaker, but they're optimized, meaning that most of the algorithms can run 10 times faster, and a couple of algorithms can run 3 times faster because we have a dedicated team at AWS tweaking it and optimizing it. Same thing when it comes to framework. I kind of alluded to it. We support multiple frameworks, and the frameworks are optimized on SageMaker. So similarly, when you're ready, once you have built the model using the framework and the algorithms, you have to tune it, and you have to train it. And this is where you have to deal with a lot of infrastructure. But if you're using a higher level abstraction service like SageMaker, all you have to do is put your test data in S3 and start spinning the cluster. SageMaker takes care of building the cluster, taking down the cluster once the training is done. And similarly, when it comes to deployment and production environment, all you have to do is choose the appropriate instance type, tell the min and max parameters. SageMaker behind the scenes will take care of scalability, resiliency, and security, meaning that it will set up an HTTPS endpoint for you. It will take care of the health checks, node failure, deploy the instances across multiple AZs, and take care of auto scaling. So to sum it up, SageMaker is a higher level service which makes the process of building, training, tuning, and deploying a custom machine learning model. So to quickly summarize the differentiator of our AWS machine learning stack, number one, we offer the broadest and deepest set of artificial intelligence and machine learning services. I covered it, whether depending on 3 layers are meant for that. Second, as I mentioned, we don't just focus on one particular framework like some other cloud providers. We tend to support multiple frameworks. And the key point is we support a whole bunch of frameworks as part of SageMaker, but you can bring your own framework. You can bring your own algorithms using containers. So we provide that kind of flexibility. And third, you can really accelerate your adoption of machine learning using SageMaker. There are a number of case studies and customers examples where customers used to spend 6 months in building and training a model, whereas after adopting and switching to SageMaker, they could cut down the time from 6 months to a week. That is pretty amazing, right? And the next differentiator is it is optimized for machine learning. As I mentioned, most of the algorithms are optimized so that they will run 10 times faster on SageMaker than any other environment. And SageMaker Neo is one of the services because we are trying to deploy the machine learning model to the edge. Usually the edge devices have a lot of constraints. They have constraints when it comes to memory, storage, and processing. This is where you can leverage SageMaker Neo and optimize the performance and make it twice faster, to run twice faster on the edge devices. And obviously you can reduce cost by using services like Elastic Inference and Ground Truth. So because of these differentiators, more machine learning happens on AWS than anywhere else. So moving on, I'm going to hand it over to Dr. Matthew Clark for the first another case study involving artificial intelligence. But if you think about it, related to the case study that I gave regarding orangutans, the first step in protecting endangered species is to identify, and then you can tag them and track them. So this is all about identifying birds based on the sounds that they make. So Dr. Matthew, please take it away.
Thank you, Wilfred. Thank you, Wilfred. So I'm Matthew Clark. I'm a professor at Sonoma State University. I'm going to be talking to you today about bird sound classification using AWS AI. The larger goal of this project is to advance our ability to monitor biodiversity through bioacoustics-based research. Sorry. Okay, so we are currently facing a global biodiversity crisis. And just for example, there's a recent study that came out that found just in North America alone, a 30% reduction in bird species. So we're losing species, we're finding population declines. Some of the big factors involved in this are habitat destruction, declines in other species of food. For example, insects are declining as well as climate change. So we need the ability to monitor biodiversity at local scales, but also over larger, broader spatial scales and through time. The traditional way of getting data on biodiversity and monitoring changes that we see for different species, whether it's a plant, a bird, an insect, or a fungi species, is going out in the field and collecting the data, often involving eyes to look for the species or some other techniques. In the case of birds, using auditory cues to identify birds, and you collect data on field notes, for example. In this example I have, oftentimes you're relying on experts that have that domain knowledge in a particular species to identify the species. In the case of birds, there's a large group of bird experts out there. Sorry, my slides disappeared. Hopefully Wilfred can get me back on track there. Thank you. Okay, and so we rely on bird experts that we call birders to collect our data. But these birders are oftentimes restricted in where they can access different properties. They have a limited amount of time. And in terms of paying people to do these kinds of biodiversity monitoring projects, you're really limited, and there's fewer and fewer people available. And when you're trying to scale over large areas, from regional scales to say a global scale, this is very cost prohibitive to actually use people on the ground with this kind of domain knowledge. My research is actually using remote sensing to scale biodiversity monitoring through space and time. And that process involves needing a lot of data on the ground. And so we need new techniques to get these kinds of in situ field data. Okay, so our solution is to use low-cost sound recorders. These are really just basically circuit boards with batteries and an SD memory card. What we do is we put out the recorders for 3 to 4 days in different sites. They turn on every 10 minutes, record for a minute, and they're just out there recording day and night. We can then analyze the data as images, which are called spectrograms, where you have time on the x-axis and frequency on the y-axis. And you can actually see with your eyes the patterns of different sounds in these spectrograms. We then can find representative bird calls and songs in these spectrograms and apply deep learning. Deep learning technology that's been actually developed for large image databases can be applied to these spectrograms. So we can leverage the power of a lot of technologies already been built to identify things like faces, cars, apples, whatever in images, but apply that to our specific research problem, which is bird call identification. What that allows us to do then is identify different species in our data. That's the ultimate goal, is to get bird diversity data out of the sounds. As you can see here on the left, you can see these are different bird species identified by their 4-letter codes. And you can see just visually that each species has kind of different patterns. Your eyes can easily pick this out, but deep learning can do a much better job. Next slide, please. Thank you. So our project is called Soundscapes to Landscapes, and it's funded by NASA's Citizen Science for Earth Systems program. We're in year 3 of this project. It involves, specifically has to involve citizen scientists, which are volunteers. These are people from our community that just want to get involved in science, and it's really been exciting to work with these people, and a lot of them have expertise in birds that our team just didn't have. And they're willing to dedicate their time for free because they're passionate about birds and biodiversity. We also have a lot of other people involved in the project that have no knowledge of birds, but just want to get involved in a science-based project that's focused on biodiversity conservation. So we can use all of these different kinds of volunteers in our project. We have citizen scientists go out and place these low-cost recorders. And then we have expert birders, like this gentleman in the middle here who's been birding since he was 7, and knows all the birds in Sonoma County, which is about an hour north of San Francisco. And he and other birders with this domain expert help us identify example patterns of bird calls that we then pass through a pattern matching routine in a web-based system that's managed by Rainforest Connections that you're going to hear from in a few minutes. We use their system to pass a template through all of our recordings and identify example bird calls, but it doesn't do 100% job on that. And so we have our citizen scientists go through and do a consensus vote on whether it is the bird or not. All of this builds up a wonderful reference data set for us that these deep learning algorithms are hungry for. And we pass the data, these reference data, to our deep learning algorithms. So our project is in year 3, and as you can see, we've been growing in size of our data from 150,000 minutes at the beginning to 500,000 minutes today. We'll just keep growing and adding more data. It's becoming a very big data problem involving more storage space and trying to come up with a system that can process these data. And so this has brought us to AWS to build a better, smarter system that can handle all that and allow us to scale our project across larger areas and incorporate more data over time. And currently we have a collaborative team at multiple universities, at a large nonprofit, and we're all trying to work on these data, and it's been very difficult to work in that environment at different institutions, different infrastructure, and different access to the data, and trying to stay on the same page is challenging. So we've been working with an AWS artificial intelligence evangelist engineer to help us design a smarter system in AWS. And this has allowed us to create a whole prototype pipeline for processing our data, where you put data in an S3 bucket, sound data, sound recordings, 1-minute recordings that get immediately servers get spun up and cut those data into 2-second clips and turned into spectrograms. These spectrograms can then be used with our training data in a Jupyter notebook to build deep learning models, convolutional neural networks. This is so easy. It's something that I'm actually not a hardcore Python deep learning programmer, but I could use a Jupyter notebook and use in the GPUs on SageMaker that are quite powerful and can allow me to build very complex models very simply and quickly. So this has been really revolutionary for me to get access to this technology and start playing with different parameters on my own without having to rely on our graduate students. Once we have a model, we are building an inference batch transform job that also involves lots of little servers that go and apply deep learning models to our 2-second clips. So to summarize our experience with AWS so far, we found these 4 different properties of AWS to be really exciting. First, it's scalable. As we add more data, it's easy just to add more storage and computing resources as we need. It's highly collaborative, which is very important for our group. It allows us to get across different universities, firewalls, security protocols, and get access to the same data with the same code base, same environment. As people need more servers, they just spin them up and they can work in SageMaker or other EC2 instances, for example. It's very cost effective. I don't have to, out at the beginning buy an expensive server that's just going to depreciate over time. I don't have to hire admins to administer the servers and worry about security. And then really important for us is it can be highly automated, as you see here on our left schematic, that we can make this so simple that a lower level technician, maybe a student or somebody else working in our project, can actually upload the data into our S3 bucket and automatically turn that into useful biodiversity data through the whole pipeline. Next slide, please. Okay, So our plan for AWS adoption is right in the middle of phase 2 right now. Our phase 1 has involved using graduate students at our multiple universities. One university at UC Merced, they're developing CNNs on desktop computers. We have been fortunate to have access to a high performance cluster at Northern Arizona University to do our inference, which is applying the CNN to all of our data. These database predictions then get handed over right now to a nonprofit organization called Point Blue to put into a database. So you can see it's very disconnected, and at times we've had to actually ship hard drives with data among our different institutions. It's very inefficient. So in the interim, we've been building out this AWS pipeline. We're using free credits from a Cal State University and AWS partnership. We've been also to use time from an AWS expert, an AI evangelist, to help us build a smart, cutting-edge pipeline that we've been prototyping with our data. And really important, you shouldn't overlook this, is this whole partnership that we've had with AWS has allowed me to better understand the costs involved and build a smarter proposal. So going forward, I can actually fund this whole project. And so we have submitted 2 new proposals to NASA over the summer to scale our project to Sierra Nevadas, a much larger region, the whole bioregion, much more data. And in that, we had smart estimates of what we need to do this job. So I really thank AWS for that opportunity to work through the pipeline and costing of the whole process. And thank you for your attention. I'm now going to pass this to my next presenter, Nicholas.
Okay, hi everyone. My name is Nicholas Jacquard. I'm the Principal Artificial Intelligence Architect at Orbis International. And today I'm going to talk about our effort to fight preventable blindness using artificial intelligence. So just to give a brief introduction about Orbis as an organization, we are an international NGO that aims at transforming lives through the prevention and treatment of blindness. And the reason why this is our focus, around the world, more than 250 million people are blind or visually impaired, and up to 75% of these cases can be readily prevented or cured. And this is with current treatment available and with current surgical procedures. So this is why this prevention and treatment is a laser focus of ours. We have a digital arm to our mission at Orbis, and this is called CyberSight. And our vision is to make CyberSight the world-leading eye-health learning and mentorship platform. And there are 4 pillars and components to that strategy. The first one is CyberSight Consult, which is a telemedicine platform whereby you have healthcare professionals in low-income countries that will submit patient cases to the system, and they will be paired up with international ophthalmology experts around the world, and together they will work on a patient case. And through this process, the local patient in low and middle income countries get the best possible care, but also the healthcare professionals in the regions and communities will, through this mentorship program, be more able to cope with these complex patient cases in the future. There's also CyberSight Learn, which is an online course collection in ophthalmology, nursing, related fields. There are programs such as remote web lab training, and also it is a library of lectures, surgical videos, textbooks, and manuals. And finally, there is CyberSight AI, which is the main focus of this talk today, which is an open access platform for automated interpretation of retinal images. And those are images that are acquired using fundus camera, which are cameras that are used in ophthalmology. For example, if you go buy new glasses nowadays, you will get your retinal image taken. And there's an example here of a retinal image. And what this platform does, it offers diagnosis recommendations, as well as provides visual aids and clinical decision support tools so that healthcare professionals accessing the platform can make the best possible decision when dealing with a patient case. So why AI in ophthalmology and why now? So the kind of numbers that underline all our efforts is that by 2050, the number of people blind around the world will triple. And there is an urgent need to develop the technology and the processes to try to minimize that number as much as possible. And in order to do so, there's a few pressing issues that need to be tackled through technology or otherwise. And the first one is it has to do with community screening, which is where we go to the patients directly where they live to screen them for potential eye disease. And the typical process is that once it's been screened, if the screen is positive, they will have to travel to a central facility for treatment. And in many cases, a central facility can be hours or even days of driving away from where they live. So you have to be really sure that the patient is positive for a given eye pathology before referring them to the central facility. And this solves two problems. The first one is to avoid unnecessary travel from the patient, which can be a huge inconvenience in most cases, and also minimize false positive referrals to the central facility, so you do not overrun the facility with patients that should not be there in the first place. There's also a significant shortage of local experts in these communities, and there's a need to allow, where possible and where safe to do so, to allow non-experts to take part in the clinical workflow. And also something that is true for almost all areas of medicine, timely detection is very important for eye disease, and there is a need to detect sight-threatening conditions early so that treatment can be administered as soon as possible and hopefully lead to better patient outcomes. And there are mainly three areas right now where AI can make a huge difference. The first one is through augmented intelligence. And we are not after autonomous AI. So in all our workflows involving AI, there will be a human making the decision. But through augmented intelligence, we can provide a second opinion, or we can upskill non-experts to make them able to participate in that clinical workflow. We're also building machine mentoring tools where we're using cutting edge AI to not only diagnose eye disease, but also to create these tools that will teach the future generation of local healthcare professionals to how to tackle these patient cases as best as possible. And we're also working toward more efficient clinical workflows. And an example of that is minimizing time to get a result. So instead of waiting hours, days, or weeks to get a result from a screening, you will get it right away, which allows you to prescribe a treatment, and hopefully by treating early, then resulting in better patient outcomes. So CyberSat AI is our AI-enabled platform for clinical decision support and mentoring in eye care. Behind the scene, it is powered by about 20 machine learning models that are specifically trained from scratch to detect sight-threatening conditions. And after you submitted a couple of images, so you have typically you have an image for left eye, an image for the right eye of the patient, you get a full set of results within 10 seconds, which means that if you're in a community screening setting, you're able to give an outcome to the patient or a referable yes or no outcome to the patient right away, which is, as I mentioned, very important when you refer them to central facilities for treatment. The platform is available in 140 plus countries around the world, and most importantly, it is completely free of charge to access it for users in low and middle income countries. And this is extremely important for us, as we have this aim to make sure that no one is left behind by this AI revolution in healthcare. And this is one way we're doing this, is to make sure that there is no cost of or no barrier of entry for users in these countries to access our cutting edge AI. It is also an API first platform so that it can be easily integrated, for example, with patient management systems, patient record management systems, or with other AI solution provided by third parties. So everything can be nicely integrated and provide a unified interface to control all these different systems. And finally, something very important for us is we have a huge focus on quality, clinical validation, and patient satisfaction. Everything we do in the AI space is in the service of the patient and with the aim to improve patient outcomes. So very briefly, I'm going to describe our AWS stack. everything we do at Orbis in the AI space is fully containerized. So we both the backend, so we have a Python-based backend, and we have a front end, which is a React application, and we have inference servers for machine learning. All of this is containerized and orchestrated using Kubernetes. And in our case, we're using Amazon's managed Kubernetes service, which is AKS. We also are using SageMaker. Right now, we're mostly using SageMaker for managed notebooks to facilitate, rapid experimentation with data science, machine learning pipelines. But we're also exploring using SageMaker endpoints to facilitate kind of scalable machine learning inference without having to worry about the infrastructure behind it. Because right now we're doing this in Kubernetes, which means that we still have to maintain it to a certain extent. We're using Global Accelerator to make sure that all our users around the world, as I mentioned, we're in 140 plus countries, so all these users can access our services with as low a latency as possible. And we're using Amazon S3 as a storage solution, both for the machine learning side of our operation, which is hosting, I think, 25 terabytes of data that we use for the training of our machine learning models, but also for the operation and productization side, where all the artifacts created by applications, so for example, a patient report, are also stored on S3. And we're using transfer acceleration so that our users can also get low latency access to all these artifacts that we're producing, so that someone can download a patient report and download as quickly as possible. And the last point is kind of an experimentation of ours, but we are started to look at Inf1 instance types, and those instance types have been specially designed with custom hardware to handle inference tasks for machine learning. And as I'm going to briefly mention next slide, running complex machine learning pipelines and models is quite expensive because you have to use a bunch of GPU nodes. And we're looking into using Inf1 nodes, which are for, as far as we understand, for similar performance, it is a fraction of the cost of using GPU nodes. So we are really excited about using this instance type in the future. So just before I finish, 3 lessons learned through our journey to productization of our AI applications. The first one is we have a very global audience, and the way you would typically tackle that audience is you would have cross-regions deployments of your applications, which is doable. But if you have a relatively small DevOps team like ours, it can be very costly and very complex. Whereas we found that using services such as Global Accelerator and transfer acceleration for S3 helped us a lot to reduce latency for most of our users while minimizing the number of deployments we need to have in different regions. So it's minimizing costs for us because we don't need as many cross-region deployments that we will do otherwise, and it also improve latency significantly for users around the world. The second point is more about a general point about building versus buying. And there's this temptation, and we were guilty of that at Orbis and for myself in my previous life in tech startups, to try to build bespoke tooling for your application because you're saying, oh, our requirements are very different from other organization in the field, and we need to build our own tools. But from personal experience, what you end up with, especially in an organization where the tech team is relatively small, is that the total cost of ownership ends up exceeding what you'll get by just buying that solution to begin with. And you end up with a bunch of technical debts that you will have to pay at some point, but by keep maintaining these tools that can add complexity to your stack. So where possible, I definitely recommend to buy over building, especially for NGOs and similar organizations. And the last point I wanted to make is about the cost of AI productization. I mentioned that we have about 20 machine learning models running as part of our stack, and they are continuously running, so they have to be available 24 hours a day, 7 days a week. And it becomes really expensive to have as many GPU nodes running continuously. And that's not taking into account if you want to add redundancy to that system when you have, more nodes just to have more compute available in case of a spike in traffic. So you can alleviate some of that through clever use of Kubernetes orchestration, and for example, through the use of Spot instances on Amazon Web Services. But we're also looking at SageMaker, and more specifically the use of inference nodes, as I mentioned before, to further reduce that cost and hopefully allow us to grow the number of models that we have in deployment while reducing our compute bill at the end of the month. That's it for me. Thank you very much for your attention.
Deforestation is a social issue and it's a threat to biodiversity. And there are alarming statistics out there, according to which we might have only 10% of rainforest left in a decade if we don't act right now. A lot of species can go extinct. That includes both animal and plant species. And deforestation is a major cause for global warming. Topher White here is on a mission to fight deforestation using artificial intelligence. And let's hear it from Topher.
Wilfred, thanks so much for the opportunity. So Rainforest Connection is a nonprofit startup based in San Francisco. We're a tech startup building tools and technology and partnerships around the world to help fight deforestation. Our goal is to help fight and stop deforestation, on the whole, illegal logging throughout the forest around the world. There's lots of technology tools that others have built in the past that's been really helpful in doing it. Technology like satellites, camera traps, community monitoring with smartphones, drones are of course the solution to everything, and sort of using phones and planes to actually monitor large areas. But here's the solution that we have. The moment that a chainsaw goes off in the forest, the sound is picked up by our devices up in trees, transmits it up through the cloud to rangers on the ground. You can actually get the alert and head out there and actually catch the loggers on this spot in this perfectly realistic rendition of exactly how it happens. But of course, it's important to have some hardware up in the trees. And so for us, we actually take, in the past, we took old smartphones, and now we have new devices that take solar panels and microphones. We put them high up in trees. They can listen to all the sounds of the forest. And of course, this is great because there's lots of sunlight up in the tops of trees. You can actually pick up the sound of the forest, which you'll see is a really, really amazing way to hear what's actually going on. So really, if you think about what's there, why would we take this on? Well, it turns out that deforestation, as Wilfred said, is one of the biggest contributors to climate change. More than all the transportation put together comes from deforestation. So it's all the cars, trucks, plane ships combined don't add up as much. And the logging itself in the rainforest, up to 90% of the logging in the rainforest is from illegal loggers. So this actually could be a really great way for us to stop it. Now, not all deforestation comes from logging itself, but as you can see here, logging is so profitable, they'll actually use logging trucks to go in there and take out the most expensive wood. They'll cut a road in there, and once that road's been there, it actually will go in and burn and create farms. And this is actually really the wholesale destruction of the forest. So if you can actually stop the illegal logging, you can stop the roads. If you can stop the roads, you can stop the wholesale destruction of the forest, which is why stopping illegal logging, which you saw there's a mandate to do because it's mostly illegal, might actually be the fastest, cheapest way for us to fight climate change today. And based on that, the devices that you saw earlier, one of those devices can hear the sounds of chainsaws really far away, like up to 1 kilometer in the distance. That's 3 square kilometers of forest that's covered. That's 15,000 tons of CO2, equivalent to 3,000 cars off the road for a year. And of course, we don't have to cover every square inch of forest. You can cover the perimeter, and so you can have a much bigger impact. So just to recap, here's how it works. Again, the moment that a chainsaw is picked up, it transmits through the cloud to rangers on the ground who actually show up and stop it on the spot. And this, of course, ends up being almost like a nervous system, a response system for the forest. This 1, 2, 3, 4, this loop of how we actually are able to detect threats and get the right people on the ground who have the right to stop them there in time. It's really one of the most effective ways for us to take this problem on. So let's actually see what this looks like in the field. So if we go to the Amazon, one of our biggest projects, you can see the Amazon edge. There's this ocean of deforestation with these patches of pretty intact forest. What is up with that? That's actually indigenous reserves. They're not traditional protected areas. This is the Tembe Reserve. It's about the size of Yosemite National Park. This is the Tembe themselves. And if you look here, you can actually see the Tembe. When we met them in 2014, this entire purple area was occupied by illegal loggers and settlers, such that even just moving from one town to the other, they would be running up on illegal loggers with new trucks, well armed, really, really dangerous stuff for them to deal with. And they realized that for them, this was really a matter of survival. If they wanted to protect themselves, they would actually have to take this on, because there's no real law enforcement in this area. It's entirely up to the Tembe to protect themselves and by extension, the forest. And of course, when you see the area that you're looking at here, it's actually really, really, really large. So for them to train rangers and get out there, again, it's the size of Yosemite National Park. How are you going to have 30 young rangers actually be able to stop it? And so it turned out that we were able to put our devices up in trees. We trained them, as we do, local people on the ground, to actually put them up to 150, 180 feet up in trees, so they can hear sounds even further away. They can pick up cell phone service even further away. And we're able to train local people to put these devices up in trees, and they themselves become the both the installers and of course the users of the system. So let's see what this actually looks like in practice. So here we have the sound of a chainsaw in the forest. Let's stop and listen. So see if you can hear the chainsaw. Hopefully you can. Go for it to hear the chainsaw. Exactly. So this is actually a chainsaw just a few hundred meters away, not terribly distant. So being able to pick this up with AI, and again, this is using a TensorFlow model up in the cloud, is not terribly impressive. But again, this area we're talking about is so large, you have to be able to protect so much more. And so again, here you have this area that's this large. Let's look at one that's really from the field itself. And here's a chainsaw that's really actually well over a kilometer away. If you can hear the chainsaw in the distance, it's really, really, really very, very faint. This is why AI is so important for us. This is where CNN is able to pick out very, very faint chainsaws that people would not. And this is really important because when you can have the machines out there listening for it, you can get people to do the difficult part. So in this case, this chainsaw alert from the forest is able to scramble, get the Tembe Rangers out to the that they were able to intercept this truck at the end of the road. And really at the end of the road, you had 30 young Amazon warriors who were able to catch this truck in time. And of course, they were able to catch the equipment. They were able to arrest the loggers, send them on their way. And again, this is where it becomes so important. These guys were able to take law and order and of course, environmental protection into their hands. They were able, of course, to take law and order in their own way, destroy the tractors, again, do the same thing with the truck. But again, this is what's really what's happening. These guys are on the front lines of conservation. These are the ones that we have to help. And that's what really sort of gets to us, is that we can build tools to economize energy. We can build tools to do so much more, but this guy protecting his own backyard in the Amazon forest, just trying to defend his own history, his own culture, and his own forest, can have more impact on fighting climate change than a dozen engineers working on economized energy solutions. And that's why sometimes the best technology we can build has nothing to do with us. It's about helping the guys out there, like this one, really make a difference. It could be the fastest, cheapest way for us to make a difference. And this is not just in Brazil. We've been doing this all over the world. 14 countries that we started on 5 continents, protecting nearly well over 3,000 square kilometers of forest. And even now, as we speak, as you're watching this, our team is fanning out across the world, even in spite of COVID, installing well over 100 more of these in 4 new countries, thanks to the support that we have from our corporate partners. And so really, this is us just the beginning of what we're trying to accomplish here. And based on those new projects, again, 3,000 square kilometers of forest has been covered. Over the next year, we are quite sure to take on well over 6,000 square kilometers of forest, and the carbon impacts of that are immense. That's 30 million tons of carbon, 6 million cars, the equivalent, off the road, and that's really where it becomes such a thing. So we talked about the nervous system of our planet we're trying to build. Again, the sensation, perception, cognition, response, those 4 steps. Well, we build this all in a cloud-first approach on the AWS platform. So we spoke before about these guardians up in the trees that are capturing all the sound. They're streaming that sound up into the cloud, and that's where we do the analysis. It's coming in through a broker running in Kubernetes. And again, that's where we begin to really break it down. And it's not just about being able to send response alerts. There's so many more things we can do with it. We're making incredible use of the scalability of the cloud, including Lambda functions. Of course, the amounts of data coming in require us to build a very large queues. And we are archiving all of the sound from the forest, building up this huge, almost audio arc of the sound of the forest in S3. And of course, making use of the ability to query it really effectively with RDS really matters a great deal. But it goes so much more than that. Again, we talked about the threat detection and getting people there to stop it. But what if we could make it possible for anyone around the world, as we have here on our app, to listen in to the sound of the forest and really kind of connect with what's there? That's what the same cloud architecture makes possible. If we can send an alert, we can actually stream up live audio feeds from the forest, and anyone can listen in. And it really matters because, again, not just for pleasure, you can have scientists using the exact same tools that we're hosting in AWS to get in here, annotate, and begin to feed and improve upon this AI. So this is the Acoustic Explorer that we built, the ability to actually listen in, say that's a given, I'm going to add this species to a database. This becomes annotations and actual tags and labels that can auto-train AI using machine learning as well as computer vision techniques. It's these interfaces, these ways to get to the data and make it available to scientists, enthusiasts, and the rest of us that can make a big difference. And so in this case, this one image you see here, this annotation, can then be fed into Arbamon, which you actually saw in one of the presentations earlier. Using computer vision, we can very, very quickly with Lambda functions spread out and actually pull from a huge data set examples of that animal call. And then once you can do this and scale it up, that's when interfaces like this really come into play. The ability for us to actually, well, I'll stop and listen. Here you can listen to the sounds of Sumatra, vehicles, crickets, gibbons, birds. It's all there, happening in real time on audio feeds coming out of the jungle, just allowing computers to actually go and pick out the subtleties of ecology in the way that all these animals are working together, all the ways in which nature itself is composed when no one's actually there to listen. We can do this with wide-scale acoustic monitoring in AWS. And it's really just amazing what's in front of us. The ability to go super precise down to the second and see way animals interact, and also zoom out over the course of years. It's really leading to a really amazing moment that, that only the cloud can allow. And we really hope that it's going to lead to a whole new era of discovery, potentially as important as the discovery of the microscope. That's what's really in front of us, thanks to the scalability of the cloud with AWS and the really importance of the problem that's there. So thanks a lot for your time.
Thanks, Topher. I loved your presentation. And once again, Topher, Nicholas, and Matthew, thanks for your time today and for the great presentations. It was very insightful, and we learned how we are using AWS Machine Learning Stack and the cloud computing platform to build workloads that make difference in people's lives. So for those who have been listening, or for those who are listening, thanks for your time. And if you're building any kind of cognitive systems, or if you're building applications that needs deep learning or machine learning assistance, we are standing by. I have a team of machine learning experts, and the charter of our team is to work with partners like you to build machine learning workloads on Amazon. So reach out to us directly, work with your partner development manager, or work with your account managers, or directly send me an email. My email ID is wilfredj@amazon.com. I've also provided a couple of links. You can navigate those links to find more information about AWS Machine Learning Stack, documentation, case studies, and customer references. I just want to highlight one thing before I close. That is the Rapid Adoption Assistance Initiative for public sector partners. So if you're a public sector partner in APN, we launched a Rapid Adoption Assistance Initiative. And all it does is it provides you a form for your technical architects and technical people who are actually building the solution. You can go to the website mentioned there, fill out the basic information about the workload that you're building, and probably you can mention a couple of AWS machine learning services that you're planning to use, and the primary contact information of your lead architect. Within 3 days, we'll reach out to you and we can figure out the next steps. As I mentioned, we can help you in the discovery phase, meaning that we can validate your approach, we can validate your architecture, and we can also provide you hands-on assistance, hands-on keyboard assistance, and enable your team, technical development team, on machine learning stack. So once again, thanks for your time. Looking forward to be collaborating with you to building more workloads for public sector customers. Thanks again.
Thank you everyone for attending today's webinar, Drive Meaningful Outcomes for Better Societal Impact Using AWS Artificial Intelligence. You will receive a follow-up email within 24 to 48 hours with a link to view a recording of today's webinar. Thank you for your time and have a great rest of your day.